Hello, my name is Jessica Ahner. I am a senior at the United States Air Force Academy in Colorado Springs. I am an electrical and computer engineering and applied mathematics double major. This past summer, I have been a part of the Robotics Institute Summer Scholars, allowing me the opportunity to work in one of the amazing robotics labs at Carnegie Mellon University. I worked in the Intelligent Autonomous Manipulation Lab with Dr. Oliver Cromer. He was a great mentor throughout the program, and I enjoyed being a part of his lab. My project is titled Object Manipulation with a Simple Box Gripper. The reasoning behind this research comes from the trade-off between design complexity and functionality. A complex manipulator, like a dexterous hand, will be much more successful at specific tasks, but we do not always need such a complex design. For simpler, broader tasks, we should use a more general manipulator design in order to be more efficient. This research works to show that the creation of a simple box gripper can have sufficient capabilities to complete tasks without the added complexity other manipulators possess. What is a box gripper? A box gripper is a new concept that has not been thoroughly explored. We are combining the previously researched ideas of a simple hand design and box manipulators that use extrinsic dexterity to aid in object manipulation. Our box gripper is not only a box manipulator, but it also acts as a simple hand when it picks up and places objects. We began by designing a box gripper to attach to the Franca Panda robot. In the CAD image on the screen, you can see the two supports on the sides to attach to the robot and the barrier wall in the middle of the box that will aid in the assortment and collection of objects. There is also a scooper attached to the fingers of the Franca robot arm. This allows the scooper to fully cover the bottom of the box when the fingers on the robot close. Our first manipulation strategy was grasp and palm. The box lowers over an object, the scoop moves under the box, picking up the object, then the robot begins a series of tilts. Shown in the image, we can see that series of tilts that moves the object to the back of the box. The next manipulation strategy was unpalm and release. Here, we would pick up a second object while the first object was stored in the back of the box. Then the robot would move in another series of tilts, as shown in the picture, to move both objects to the front of the box. From here, the box would lower and release the objects in a precise location. For our results, we found that rounded objects could easily be manipulated inside the box. However, the release was difficult because the objects would often roll away. We also tested this box gripper on many different kinds of objects, like die and screws. Through this, we found that the gripper and strategy we used generalizes to various different objects. The main failure mode was objects getting stuck on the edge of the scooper or on the rough 3D printed surface. The projected future work involves box grippers with task-specific barriers for more accurate assortment of objects. This could include adding more complex barriers and structures inside the box. Exploring different material and surface properties for the box gripper is another great area to continue research. Using a 3D printed box gripper had many limitations due to the rough surface with high friction. A smoother material would provide for easier manipulation. Other possible next steps could be adding a camera to observe objects in hand and developing new strategies of in-hand manipulation with the box gripper. We ran experiments with the screw and found that it would be interesting and beneficial to manipulate the screw to stand on its flat side. This would help aid in screw manipulation. There are many other directions this work can go in the future. These are just a few. That concludes my research done on object manipulation with a simple box gripper. I would like to thank Dr. Oliver Cromer and the Robotics Institute at Carnegie Mellon University for this amazing opportunity.